Today we're going to be talking about diver-assisted vegetation removal, particularly milfoil. So with that, I'm going to turn the meeting over to Eric Gustavsen and Gerald Principe. I didn't do the Italian version.
No, you did.
Principe.
So we're actually going to start with a quick video that shows what we're doing, and then we'll speak about it. So this video shows our diver-assisted suction boats in action at Green Pond. And it's a nice way to kick us off.
That's the end.
Yeah. Yeah, you can kind of hear them snapping as you get most of them. Here's the camera going up the hose. So these are the bags that it goes to, the plants go through a sluice, they get bagged up and they get disposed of at the end of the day. Team. A lot of interesting finds in the bottom of the lake. So hi, good morning, everyone. My name is Eric Gustavsen. I'm here with Gerald Principe, and we're involved with the dive team at Green Pond. And you see the word Hyglin in our description, which is the name of our 501c3 not-for-profit organization that supports our efforts. So I'm going to just spend a few minutes with some of the basics of how we started and the main components of this team. You saw the video. One thing I wanted to point out in the video is that in contrast to the meeting you had last week about dredging, this is kind of we go through certain steps to not be dredging. So the hoses that you just saw in that video are suspended by flotation devices, by buoys to the surface, so that we're specifically not doing any bottom dredging. We're pulling plants, or we're just using that as a way to transport them to the surface. So let me run through this. Do I click this here?
Yeah, the next arrow?
Yeah. So we don't need to get into too much about milfoil. We all know what it is. We all know why it's a pain in the butt. It spreads. It takes over bodies of water. First came into the U.S. in the 1900s, early 1900s. Rapid growth and propagation. It loves certain lakes. It likes our lake. And we all know the negatives about impeding recreation, decreasing property values, adding cost of management, things like that. This is our demonstration site, which is Green Pond, not far from here. Glacial Lake, about 2.5 miles long and a half mile wide. And we have about, I think, 300 acres, and it's, I think, a different slide, but we have about 300 of our roughly 500 acres is susceptible to Eurasian milfoil growth. Highlands region, average depth is about 15 feet. Let me go back one. So about 65% of our residents live on the shoreline, and the west shore, which is this lower section, use the lake water for bathing, for doing dishes, for brushing teeth, and things like that. Sorry, can we stop on The wires all seem intact.
Yeah, this one too. It's that yellow color.
Eric, would you like to have questions during the presentation?
Sure, that's fine. Yeah, you can interrupt me. You can interrupt us. Sure, that's fine. In fact, now's a great time.
Is the mic still working?
Yep.
It's coming on.
Maybe I didn't go fast enough to the call. Here we go. Yeah, the camera's the camera.
Yeah.
Yeah.
Does this require a permit because you're disturbing lake bottom?
It does not, because we're not dredging. So in other words, you're allowed to pull something.
Even though you're pulling something out,
Yeah.
it doesn't require?
Exactly, because you're not removing, you're not specifically removing any substrate or sediment. It just kind of comes along with the roots. What dredging would be if we put that device on or near the bottom.
Okay,
So
so we always
it
thought it was anything that disturbs the lake bottom was.
From our understanding, we don't need a permit for this just because we're keeping the hose ends elevated off the bottom. Exactly. There we go. Got it. Thank God for tech support.
I don't know what side you're on.
That's okay.
Ready to hand.
Yeah, so we'll go. We first observed Eurasian water milfoil in Green Pond in 2013, and then we started to see curly leaf pondweed in 2018. And one of the side benefits of us having this team is that we're able to pull whatever we want, but we pull Eurasian water milfoil and curly leaf pondweed as we see it. So we're able to tackle invasives and then leave the natives alone to have a healthy plant population. We did have some past herbicide treatments. So in 2014, we treated 1.5 acres with reward. 2015, there was no treatment. 2016, we did 2 acres with reward. 2017, 3 acres. 2018, no treatment. In 2019, we did treat 20 acres, but the lake was also closed that year to recreation due to how much Eurasian water milfoil that we had in the lake. And this really started as a grassroots effort organization where we went out and bought some battery-powered hookahs, a couple of us, and just started to test what that would mean to dive down with bags and pull plants. We found it to be very effective. We were able to clear areas and be very selective about what we pulled and where we pulled. So we formed an organization called, I'll move through this quickly so we can get to the science part. I know we have a certain amount of time. We formed an organization called Lake Watchers to monitor the lake and search for these invasives and make sure that we were sharing those reports. We started hand pulling on a volunteer basis, but the volunteer method of hand pulling really wasn't viable long term, we found. People would come out, they'd help, but it's really hard to sustain that long term. We also, then we formed a milfoil advisory committee called the MAC, and that had volunteers from all over the lake, from interested stakeholders, from members of the MAC. We researched other lakes to find out how they were handling this. We found several that were successful with hand pulling efforts. Princeton Hydro also recommended hand pulling as part of one of our tools for invasive management. That's Green Pond's lake management consultant. And then we also tried to find a dive team to do this. So we reached out all over the Northeast to try to find a dive team that could do it, and really to no avail. We were not able to find any group or team. We did find one that said they could do it, but then we heard from the grapevine that they were hustling trying to find a boat and equipment before coming onto our lakes. We realized that they were not the right group.
Eric, don't feel rushed. It's plenty of time.
Okay.
It's good stuff.
Okay. Then a group of volunteers created this AER&M. There are way too many acronyms here, but it's the Aquatic Environmental Research and Management Dive Team, and Highland, which is the 501c3 were formed, really is the body to make this happen and manage this. Our methodology, and it's nice that you got to see the video first because you sort of see how it works. We have two roughly 20-foot, a little bit bigger pontoon boats, and they're just very basic stripped down pontoon boats. And what you can see in this image is that we use some large drums that serve as the sluice system where the bags hang on either side. The hoses on the left side you can see are what transports the plant matter up onto the deck with two pumps. They feed through a sluice, they get bagged, and later on they get put in our compost area in a separate area. So it's based on a pontoon boat frame. We do use we plot all of our actions with a Lorentz where we can look back and see every spot that we visited on the lake for both boats and get a sense of how that matches up with where we've seen plants and historically where we know that there's a lot of growth. We use a Venturi suction system, like I said, that brings the plant matter up to sluice boxes and separates it. We also can make sure if there's a turtle or a frog or something that rarely gets caught, we can let them go again. And then we have a hookah system, which is the orange pump you see on the left side of the screen, and that powers that's enough air for sustained diving for two divers for as long as we need. And as I said, the 50-foot suction hoses and buoys that keep them elevated off of the bottom. I mentioned the surface supplied air system, so we use a Hookah Max air compressor and we use OTS Guardian masks. What we like about that is that we have diver to surface communication. So at all times, even though it's shallow and not dangerous per se, it's still diving. So the divers are in constant communication with a foreman on each boat. And that might be just helping them figure out where the plants are, or it might be speaking about an issue that's happening topside. There's an image of the mask and the equipment. There's one of the boats out of the water. You get a better view of the two Venturi pumps that allow us to suck up the plant matter into these sluice boxes and then into the steel tanks, as you can see. Recruiting is one of the most important parts of this because it's not easy to find divers, but they're out there. So we found that we speak to dive shops, we use Indeed, and we've learned that as we get into these networks of people and they have friends and they recommend people, there is a whole kind of subculture of divers. Some of them have just graduated commercial diving school, and this is their first experience, which is a great first experience because it's not, New York Harbor in cold, foggy water. It's 15, it's summertime diving in 15, 20 feet of water. And our requirements are that the divers be 21 years old, they're open water certified. We do Zoom interviews, then we do in-person interviews. A lot of divers are a lot more experienced than that. Some of them have advanced and rescue and first aid. We always have a first aid person on each boat, and we keep oxygen on each boat for emergency need. The divers supply their personal gear, but we supply the masks and the hookahs and things like that. And the way we break up our day is that we do a 10-hour day, and there's an hour in the morning of setting up, an hour at night of breaking down, and then each diver dives roughly between an hour and a half and 2 hours per day, twice. So 2 shifts of roughly 90 minutes to 120 minutes. We work Monday through Thursday, and the idea behind that was to leave the lake open for recreation Friday, Saturday, even though it doesn't interrupt too much. We just didn't want the divers on the lake on Fridays. Yeah, and we try to keep pay competitive. It's challenging with a 501c3, but we pay the divers $24 an hour for this work. And here you can see some of the guys with bags at the end of the day. We weigh the bags, so we establish an average weight per bag, and we weigh them not dry because then it weighs nothing, and not the minute we pull it out because then it would be much heavier. But we weigh the drained milfoil bags. So when you see statistics later with Gerald about weight, what we're doing is weighing the drained bags of milfoil. So this just recaps some of the things that we just spoke about. And the guy you see in the kayak there, one thing we do sometimes is have people in kayaks with nets that follow along after the boats and help clean up fragments and things like that. That helps to bring those numbers down. So we have a buoy suspended suction system, as I said, that stays off the bottom. We try to start as early in the season as possible because we've noticed, especially last winter when there was very little ice cover, that the milfoil started to grow much earlier in the season than it had in the past. We call this method search and destroy because when we know there are patches, we can head right to them, but otherwise we're just cruising across the lake bottom and pulling things as we find it. We have a maximum operating capacity of 1,000 pounds per day per boat, which means that if both boats are out, we have the capacity to pull a ton of milfoil a day. And that's when it's in a growth, in a dense patch. When it's more spread out, it's harder to pull that amount. But if we're tackling a thick patch of plants, it's about a ton a day for both boats. We also remove garbage, safety hazards. It might be strange. Sometimes it's really cool things like bottles and anchors and fishing. How many fishing poles? Hundreds. Right.
Very bad at fishing.
Yeah. Boat propellers. One time there was a porta-john literally on the bottom of the lake. So that's all gone now. So, here you can see the bags, the sluice feeding plant matter into the bags. Yeah. Diver down with the mask. This is after a day when we cleared the swim lanes. So these are the bags lined up, ready to take to our compost area. Yeah, here's clay pigeons. Apparently back in the day, that was something that you would do at a lake and fire your shotgun. Yeah.
How do you dispose of the weeds, the bags?
Yeah, we have a designated area in our compost section of the lake. And what's funny about milfoil is that it's like what 95% water. So you can make a huge pile, and then 2 weeks later you're not sure where it went.
But you can remove it from.
It stays well away from the lake in a compost area, kind of in the woods in the dump area.
Okay, so
Yeah.
we'd have to provide a dump area.
Right. I mean, it can go almost anywhere as long as it's not right at the water's edge, because but once it's dead and pulled and dried, it doesn't pose that much of a threat.
Okay. Is there any detriment just because we're in the Highlands, subject to the Highlands Act?
Yep.
And surrounded by state park things. So is there anything that would be concerning to us is leaving the stuff out in the dump area that may be deemed?
What do you think? Nothing that I know of.
There's tons of invasive species in New Jersey, and they're typically all dumped in composting areas. It's an aquatic plant, so as long as it's far from the water, relatively safe. Yeah. You got another question?
Oh, so yeah.
On one of your slides, it said that you had more success with the pro divers, and I was wondering what that meant.
Oh, you know what that really means, I think, and I think you would agree, is that when it comes to stamina and experience, and just somebody who physiologically and mentally understands that they're about to do a lot of diving, it's really, we've had more success with guys that started out with the intent to be, I'm going to be a professional diver, and they went to school for that. We find that specifically they get less tired, they have more energy to stay down for longer, and they're just, so in those ways, and those things matter day to day, stamina and physiology and things like that. So some people actually, you can get the toughest guy in the world who thinks they're going to be a great diver, but they're just not kind of suited for it, for whatever reason. So.
So how often do you do this?
We do it for the entire season. So this past year we started in May and went all the way through, I think September 15th was our last day this year. Monday through Thursday, unless there's heavy rain, lightning, thunder, things like that.
Every year?
For the past 4 years. So we just completed our 4th year.
So
Even
it's,
how often the lake does it?
yeah, I mean, the lake, for one
Oh,
lake.
yeah,
For
how
one lake.
often would the lake?
This is all for one lake, exactly. And then
I mean, like, how often should a lake do it?
Every year.
She's asking.
oh, every year, every year.
So it's like an annual.
Yeah, yeah. It's kind of one way for future management of invasive species. It's sort of accepting that this is what we have to do. That's how we look at it. You know, it's a.
So, we're seeing improvement?
The improvement that we see is that for 4 years, we've kept it managed below nuisance levels, meaning no surface growing plants, no lake closures, no patches that you can see readily, things like that. It's still there, and you know, when we first started, I think we thought we could maybe eradicate it completely. We've learned that successful management is our measure of success, meaning that it stays.
So your lake bathymetric survey is 5 to 15 feet in that range?
The average is 15. I think.
Yeah, the average is about.
Okay, so you're experiencing this in the shallow areas?
Well, a little. We have the water's fairly clear, so we actually get it up to about 20 feet. Yeah. Sorry.
What's your take of material per year? Is it going down or is it steady?
This year
We'll
was,
talk about that.
yeah, Gerald's gonna review that, right now, but this year, we pulled slightly less than last year. But I would say that plant matter as a whole has been increasing, with no ice cover, and we're not sure of the reasons, but plant matter in general.
Have you done a cost comparison compared to how this management compares to using herbicides?
It's definitely a little cheaper to use herbicides, for sure.
But it's comparable.
Yeah, it's comparable, but if, in other words, if the calculus was just money, then you're right, it would be, it's less expensive to use, and easier, frankly.
Yeah.
Because we have, you know, the amount of hours we put in just managing this it's like a second job, right? So, yeah. Yeah.
It's nicer.
Are you doing any herbicides in addition to this? You completely stopped that?
This has really been kind of an experiment and a test to see if we could, so for the past 4 years, no herbicide, just, yeah.
Can you give us, just an approximation of what it costs for the equipment that you're using? The, you know, the pontoon boats, the compressor, the mast, special masts and all that, to set that up?
Yeah, I want to give you that whole number, I need a minute, but it's roughly, each boat with the equipment, with the mast and everything else, is in that $75,000 range. Because it really, you can use an old stripped down pontoon boat. What's that? No, but if you were to now do it, well, you know, yeah, we paid a little less than that 4 years ago, but you can use it. The boat itself doesn't matter because we have 2 old beat up stripped down pontoon boats, and then everything was built on top of that. And then we use 60 horsepower Hondas to power the boats.
Is there a liability issue with the divers that you have to?
We have insurance is definitely a thing. Yeah. I mean, there's all kinds of forms that you can sign, but in the end, really, it comes down to insurance.
And all in, you have a per acre price for this, or annually, or?
We have a per acre price for it, but it's, you know, this comes in at roughly about $200,000 for the season. And we like to look at it divided among stockholders and compare that to other lake services and other things that happen at the lake, whether it's tennis courts or landscaping or anything else. And this comes to roughly about $10 a week per stockholder, if you were to do the math that way. Even though a portion of it is paid for by the corporation, but it's.
Are you finding that once you go over an area that stays pretty much clear, or does it keep growing back at that same area?
Yeah, Gerald's going to cover that in this. Yeah.
Do you get grants for this, or have you applied for them?
No, we have not applied for them, and when we look into them, I think one of our challenges at Green Pond is that it's a private lake, so that makes grants challenging.
Would you be interested in renting this crew out on Friday, Saturday, Sunday, not collecting?
Yeah, we've actually given that a lot of thought, and what we do now is we visit lakes. People come and visit, and they see how we work,
Right.
and then we help them figure out how to build their own. That's just now speeding up now,
Right.
because people are more and more looking for alternatives. And, yeah, but yeah, we should talk about that.
Yeah, okay. Definitely talk about
Yeah.
that.
Your lake is remarkably clear. What is your setting average?
Yeah, 18 feet, 6 meters, something like that.
Sometimes less. I mean, yeah.
Okay.
And it varies where you are. There are days when I can see a crayfish on the bottom, and then I go to another part of the lake and I can't. You know, so.
I got another question with regard to, do you restrict all boating when you're doing this procedure, or is it
It's
just
really,
the area?
you could almost not notice it's happening, even if you're out on the lake. You might hear the motor a little bit in the distance,
Right.
but there have been days when I go out to speak to the team or something or say hi,
Right.
and I have to look around. So it's not disruptive at all.
Okay, so you don't restrict the boating
No.
at all, it's just in the general area where you're doing this?
Exactly, normal diving.
Alright.
Is it possible for a smaller lake to have the diver on a craft and have the hose come back to some land site for the vegetation?
Yeah, and in fact, when we visited Mountain Lake up in Sussex recently, and that's a condition that you could actually do that, because their thick stand of milfoil that they're concerned with is literally right off the swimming area. So you could combine, yes, you could.
Is there a length limit for that kind of?
Our hoses are 50 feet. I think you could do 100 feet or even 200 feet if you.
Yeah, you could make the suction hoses a little bit longer, it just makes them more difficult to move around and
So I'm going to turn it over to Gerald to, I think, answer some of those other questions, but also look at some of the science that we've been gathering, which is an important part of what we're doing. Thank you.
All right, hello everyone. My name is Gerald. I'm the dive scientist or biologist for the project. We started gathering data in 2020, and it's been 4 years now. So this presentation will cover the last 3 years. The summer of 2023 hasn't been, finalized yet, but I'll give a little insight into that as well. The dive operations in the past have started in June, but as the temperatures have gotten warmer earlier in the season, we have moved that up to May 1st. And each boat is led by either myself or the dive foreman, Gary Franco, who also is a member of the Green Pond community. So we do a bunch of research to try to be more successful at managing a large body of water. One of the things we do is broke the lake up into management zones, and these zones are determined by depth and geography of the area. So the swimming area is its own zone, the coves are their own zone, and then the deeper parts of the lake where we don't typically find milfoil are also sectioned out as their own zone, so we don't spend time looking in places where there's no real plant growth. These are the daily and weekly log sheets where we tally all the pounds removed from where, and it helps us keep track of milfoil hotspots, things like that. We also use the management zones to conduct surveys. We use transects and quadrats as our method to gather biological data, and so that's a diver on the bottom categorizing what kind of plants, what bottom type is, invertebrate activity, things like that. And this is all to try to figure out a little bit more about milfoil, or Eurasian water milfoil specifically, growing preferences. We did also put in what's called a fragmentation curtain, which is about a 3-foot net that hangs just below the surface and rides just above, and it's meant to capture fragments as they go through the water. And we put this around our swimming area to try to limit the flow of fragments in and out of this area since it's so widely utilized. This is just an overview of kind of our whole operation. Kind of talks about the how, when, and why of lots of different things. Some particularly notable figures, the team capacity. So we talked a little bit about our search and destroy methodology when we're moving through the water. The divers can pull plants as they go with the suction system suspended from the bottom. We can do about 10 acres per day with that kind of removal. When vegetation is more dense, or we're clearing dense nuisance native growth, it's a little much slower, about 1 acre per day. And this is historically what hand pulling operations, how fast they have been, which is not very fast. So with our search and destroy methodology, we can move much quicker, cover more ground, and be more successful. We have some of the things we report down here on the the bottom left, so the estimated number of plants, the pounds per zone, the number of boats and divers, so we can figure out, effort put in versus the pounds removed. The species mix in areas pulled, and estimated plant size, and all this kind of leads us to we have a contingency plan in case any of those things kind of indicate we are not keeping ahead of the growth. So, like I said, if like Eric was talking about with the maximum operating capacity of 1,000 pounds or 2,000 pounds per day, if we get to that point, it means that we're kind of falling behind, and then we would increase diving. We could sequester an area and treat it with Priscillocores, the herbicide that our corporation has used in the past and keeps a permit for in case we, in case we need assistance. We haven't needed that yet. And so you can see the hot spots that have kind of been determined based on the amount of pounds we pull, and some other data that I'll go through here. So we also do some experiments on how fast the milfoil can regrow in areas where we pulled it. This started with just one, what's called a quadrat. You can see in the picture behind the lake. We just started with one quadrat in a high milfoil density area. And so this whole quadrant was filled with milfoil when we first got there. We removed it all, and every other week we came and checked to see what had regrown. In 2022 we expanded this to be 4 quadrats, so 2 pairs, 2 different sites. One area was cleared of native plants, while the native plants were left to grow. And so with this we could compare the difference between the fragmentation success, the milfoil's ability to regrow in areas with a plant-filled bottom or areas that had been disturbed. And we also, interestingly, we have a lot of mussel activity in Green Pond, native pearly mussels, and so we put down one of these quadrats in a mussel bed area to, try to see the difference in these areas. And so I'll go through some of the results. I'll start with those, the regrowth quadrats. We identified lots of different species in that, a lot of healthy ones like broadleaf pondweed or bassweed, a few naiad species, bladderwort, which is a type of carnivorous plant that indicates good zooplankton abundance, which is really good, and other macrophytes or macroalgae, chara and Nutella species that also indicate good lake health. This is a representation of those those quadrats that we put down. So you can see that on the bottom, this is the cleared quadrant where we cleared all of the plants every time we visited. And the top one is where we just removed the milfoil and left those native plants to grow. And you can see there's more instances of milfoil regrowth in that cleared quadrant. So that just indicates disturbed areas or areas with less native plant cover. It's a more successful place for milfoil fragments to grow. Now we did classify this regrowth as fragmentation. You can tell just a little bit, you can tell by how the plant is growing, whether it was a fragment that floated in and started growing again, or if it was a root that was left behind. Now one instance we found a root left behind, but that was in the 18 observations in the last 3 years. So typically we see these roots reaching down through native plants into the ground, and a dying stalk, which is kind of helps us classify these as this regrowth as fragmentation. If you compared our quadrats, including the mussel bed quadrat, there's an interesting kind of relationship between mussel density, water clarity, and plant growth. At the densest areas of plant growth, we find some mussels, but in the dense mussel beds, we find no plants, and then the water clarity is really, really good, which that aligns with previous research that shows the ability of bivalves to increase water clarity because they filter feed. So we also put down GPS coordinates whenever the divers come into contact with milfoil, and this represents all these diver locations. This is for 2022. They seem to be focused along the bathymetry contours, which is interesting. So wherever there's more of a slope, the fragments seem to be able to land and grow successfully. Also, again, mussels seem to play a big part, and in typically high density milfoil areas, we find patches of bare bottom where there's hundreds of mussels, and their activity disrupts any plants from growing, which is interesting. Most importantly, the GPS coordinates here can show differences year to year and across a single season. So this is all the milfoil areas found by the dive team in 2022. And this is the milfoil areas found at the end of the season in September. This is before the milfoil starts to die off. It's still very warm, but you can see this indicates to us that the dive team has been successful at decreasing the amount of milfoil growing areas in the lake. So this is our removal results, so the pounds. So this says 50,000, but I think we're about 80,000 pounds of species, of invasive species removed, including 2023. There was an increase each year, with the exception of 2023, in the amount removed, but this is very likely based on yearly growing conditions. So as it gets warmer, as other things change, there's other storms, less ice cover. This is really impactful on the plant growth, and that also is consistent with literature on invasive species. It's an annual management problem that needs to be looked at every year. This is the water temperature data that we gather, and so you can see in 2022, on the left there was the hottest, the earliest. In 2023, that trend continues. So although this is too short-term data to connect with climate change, it's funny to see that every year things are getting warmer and warmer, and that does make the invasive species more likely to be successful. And kind of what this tells us is that our operation should start with the milfoil trigger temp, which it starts to grow at its maximum 2 to 3 inches a day at about 60 degrees. And so really we need to get in when that starts and not wait until the plants are at their densest, which is historically how a lot of hand harvesting operations work. And it's much slower to pull these plants when they're 12 feet tall compared to when they're 2 inches. So some conclusions. Again, we're really looking to try to figure out some things about milfoil and why it grows where. Some impacts on its growth. Hydrology is big, so our fragmentation net. At each visit, we remove hundreds of fragments from this net. This is the downwind side of the lake, so that has a big impact on where the milfoil can settle. We talked a little bit about invertebrate activity with the mussels. Water clarity and depth all are very connected. The more invertebrate activity you have, the farther the light can penetrate to the bottom, which is water clarity, and so the deeper the milfoil can grow. This year we found milfoil growing even at 22 feet in Green Pond, and it also could be, last year we had, our lake was very low. I don't know if you guys had a similar kind of drought experience, but having the lake be 2 or 3 feet lower opens up deeper areas that typically wouldn't get access to sunlight for the milfoil to grow as well. So really,
and then once it gets established, even when the water gets deep, it's still okay.
Once it's there, it's growing, right. And I think that is the main reason we see the change from year to year in the milfoil growth, and then the native cover. We did seem to find consistently that areas that were disturbed with no plants, the milfoil had a much easier time of putting down these fragments with roots and starting to grow. And we checked weekly, and so this can happen in a week. In a single week, a plant fragment can land on the bottom and start to put its roots down into the bottom. So, yep, that's great. Some conclusions about this, what makes our operation successful is the diver-assisted removal of invasive species, and how targeted we can be. We can remove just milfoil, we can remove any other invasive species, and we can also remove patches of nuisance growth in recreation areas. management of the area using zones. This helps create hotspots and better utilize the dive team's time and spend time in places that they need to be. Management throughout the growing season, so again, starting early and not waiting for these plants to be big and dense. The collection of data, environmental data, is really important to understand what we're doing and how we're impacting things, and how to be better. And then utilization of complementary management techniques. So I talked about the fragmentation curtain as well. We're hopefully going to use some other things like benthic mats in the swimming area to help help the dive team focus on other areas. And then we also have an underwater drone, which we lovingly call Millie, and that we can use in the beginning of the season before the divers get in, and at the end to wrap up and see where there's plants left or get a head start on things. Yeah, what's up?
Did I understand you to say that even though you don't have the data plotted, that 2023 was at or above the levels of 2022?
So 2023 was at or below, actually. It was just right around the same.
I mean, 2022 looked like it was very abnormally high.
It was high, and this year we found about the same amount, and we started a month earlier. So with that, and remember, these numbers are the amount that has been removed. So all of that poundage of plants is no longer there. And so although it does increase, it very much seems like, and this is in literature, studies of invasive species in the past, this is due to the yearly growing conditions. The plant can grow 2 to 3 inches a day. It can go through seeds. It can go through propagation, so roots along the bottom, and through fragmentation. So in a single year, it can reinfest an area if it's not managed. But the implications of this is that our dive operations have showed that our methodology of hand harvesting has the ability to keep different densities of milfoil growth below nuisance levels at the very least, and that's how we really measure our success. When there's no lake closures, no dense patches, no impediment to recreation, that's our goal, and it seems that we've been successful so far. So.
And removing other natives, like clearly.
Yes, yeah, so we can always keep an eye out for new invasives. Unfortunately, they can get introduced no matter how good your boat washing program is. So we can catch them early. We help the fire department with inspecting standpipes, and there's all kinds of other benefits to having a dive team. So that is that. Thank you guys very much.
So for the year that the lake was closed to recreational use, what was different that year, and what was the initial response? Like, I assume they tried herbicide and it didn't work.
Yeah, yep, in 2019, they had been managing with herbicide for a few years, and smaller treatments. But in 2019, there were just very large patches. I think 18 acres or something like that of dense milfoil growth. And so that warranted them closing down the lake at the end of the year and treating about a 20-acre area with Priscillacor.
It was an inflection point. It was a point in the lake's history where people weren't sure how to handle it. So that's so kind of in a way it caught us by surprise.
2022, the plan was to do a full lake-wide herbicide treatment. Have the dive team assist with any cleanup or plants left behind. But really, our ability, it just surpassed anything that even we kind of estimated, and so we were able to cover the entire lake and keep the population low enough that there was no, they couldn't treat. There was no dense areas of growth in 2020 that year, and so since then we've had that similar level of success. I'm just going to go to the back here. Yeah.
How is this program insured, and how are the divers insured?
That's a good question for Eric.
Yeah, I mean, we're required to have certain insurance for refund, and it's a not a conservative number. It's they want us to be very insured. So it's basically just I don't know the company that insures us, but the bottom line is that we have all the liability.
So it falls under like a workman's.
Exactly. Well, we have workman's comp in addition to that. But we also then have extra liability insurance
for this program.
Yeah. But I can give you the specifics of it.
Go ahead. Did you have something or?
Me?
Yeah.
Oh, yeah. What's the impact on surface algae doing this? Is it help, decrease, or increase?
We haven't had much problem with surface algae blooms, harmful algae blooms in Green Pond recently. We haven't seen any change in that in the last 4 years that we've been operating. Princeton Hydro does amazing water quality data collection for Green Pond and has for like 20 plus years. And so they do all the cyanobacteria, zooplankton, chlorophyll, you name it. There hasn't been any change in that in the last 4 years.
Even with the fragmentation of those results from?
Yeah, so fragmentation, this is something that comes up often. The plants are very good at what they do. They fragment on their own, and there's no need, whether we were there or not, or if there was any human activity in an area, this is how milfoil spreads, and so it fragments all on its own. We create a fraction of the fragmentation that's created naturally by all the plants in the lake. So yeah. What's up?
So you haven't noticed any difference in phosphorus with this?
No, we haven't. Princeton Hydro does that, and they do make recommendations every year for runoff management and things like that to improve. But
they sometimes say it's a boring report because it's the same.
Same.
Yeah. Yeah.
All right.
Yeah. Go ahead.
Can you talk a little bit more about the mussels?
Sure.
The mussels, what that is? Because to me, it seems like if the divers go down and take away and then we follow up with mussels,
Yeah.
that would be more permanent.
Yeah, so the mussels are amazing. They have all kinds of benefits to the ecosystem and are obviously a real big part of it.
Don't they filter 15 gallons a day per mussel or something?
Right. There's all kinds of awesome experiments, and in our quadrats, we would have a quadrat. We have 2 sites, a control site where there's no milfoil and a milfoil regrowth site. And at the control site, there are no mussels, and the water clarity is significantly less. Even on the same day, at the same time, 100 feet away, the water clarity in the areas without mussels is 3 feet compared to 10 feet at the milfoil or mussel quadrat. So the unfortunate thing, mussels can move. So if you tried to transplant them, they may stay for an amount of time, but they're going to go back to wherever they want to be in the lake. They can move faster than you would think. So it'd be hard to transport them and develop mussel beds in a lake that has a good population in specific areas where they want to be.
Hey, Gerald, sorry, just one more follow-up, because somebody had asked about the cost.
Yeah.
We're pulling in about 300 acres, right?
Well, that was the initial number, but it's more like 380 or something now, just because we found milfoil in some of the deeper areas.
So what that translates is to roughly in the range of about $600 per acre to manage it for the entire season. So it's not just, so in other words, herbicide can be maybe $1,000 an acre for one application, but this is roughly 600 acres for the entire 4-month season, is a way to look at it.
So you're managing this yourself and just having peer review from Princeton Hydro or something?
Yep.
Are you guys moving anytime soon, or?
That is yet to be determined, I guess.
So we would have to take in consideration that cost also.
Yeah, but
if we don't have wonderful people like you, whatever.
You know what? Well, there's you, and then you could run the whole thing.
That's a good one.
Is there a trade-off between the water clarity that the bivalves bring in terms of the plants growing in deeper water for the clarity and the absence of plants in the shallow water?
Yeah, absolutely. I mean, if there were no mussels and the water clarity was very poor, there wouldn't be as much plant growth, especially in deeper areas. Light is everything when it comes to plant growth, and so if the light can't get to the bottom, then the plants can't grow. to me as a biologist, it's obviously more important to have a healthy ecosystem and have all all the parts of it, including the invertebrates. At their extremes, they do offer protection against these invasive species and all plants from growing. In the mussel beds, there's absolutely no plants whatsoever, just because of the amount of movement in the bottom from the mussels.
And one of the reasons we want to protect the mussels and think about if chemicals might, because it's the one warning on the herbicide.
Juvenile mussels,
It's
yeah.
The term is slightly toxic, but I don't know what slightly means for that.
Anybody else? Hi, yeah.
How does the mussels end up in the lake in the first place? Were they introduced intentionally, or did they just show up?
They've been there for a long time. Basically, since the lake was carved out by a glacier hundreds of thousands of years ago, they've been there ever since. There are invasive species of mussels, zebra mussels, and there's some others, but we just have the native pearly mussels, which are the big kind of black and brown mussels that you see sometimes.
And they don't taste good.
They're not like salty and stuff like that.
Our raccoons love them.
Yeah.
They sure do.
And the mink love them.
Anything else? Hi, yeah.
Hi, I take it you're a full-time biologist with this association?
Seasonal, so May through October.
Okay.
Yeah, this is it.
Is there other full-time staff? So far we have a biologist and divers
Yeah.
in the season.
There's
Just
no
curious your structure.
there's no full-time staff. The rest of the people are volunteers. So.
Yeah, I mean, I started doing the staffing outreach in January, so you could call it a 7-hour-a-week job for the year sort of thing, maybe. So yeah.
Anybody else? Yes.
When I compare herbicides to harvesting, I think about the idea that herbicides are knocking down plants and that's going to add to the muck out of the lake and kind of reintroduce the nutrients.
Yes.
This seems to be a great way to pull the weeds plus some nutrients with it. Is that your approach?
Yes, absolutely. It's better than having the plant material decompose, for sure. That's nutrients that aren't going to stay in the system. But on a larger scale, pollution from runoff and construction projects and development has a much greater impact than plant decomposition or anything like that. So it's helpful, for sure. It's better than the alternative, but there's a lot of other more impactful nutrient flows into a system, if that makes sense.
Sure.
Anybody else? All right, well, thank you very much. We'll be we lost your chance here.